Calculus! This is AP Calculus! Unit 5 pretest solutions. Okay, so we haven't really done a video for pretest solutions, but this was the first pretest where there's so many that were missed that we want to go over a ton of them. So let's go ahead and get through this. This is the Unit 5 pretest for AP Calculus AB, antiderivatives. Let's go through these. So number one, we have this graph. You guys have a blank pretest in front of you. That means you are following along with any question that you have questions on. You can look at your actual pretest that you still have in your binders to know which question you missed. Let's do this. So we have vertical tangents at -1, -1. We've seen this problem before, and 1, 1. We also have this sharp corner up here at 2, 2. So those are the 3 points that are not differentiable. The correct answer is D. Questions about number 1? Number 2. Raise your hand if I'm going too fast and you want to slow down and take some notes. If y equals to 7 is a horizontal asymptote, so it's just the definition of a horizontal asymptote, which of the following must be true? Horizontal asymptote, as soon as you see that, that is the limit as x goes to infinity or positive or negative infinity, either of those. So immediately that one is not, that one is not, that one is not an answer. It's between b and e. And the horizontal asymptote should be equal to 7. That's -7. It's not b, it is e. Everyone got that one correct, so that's why I went through kind of fast. Number 3, I guess I'm going through all of them fast though. This one is a hotbox question. So we see something with H on the bottom. If you ever see H's, it's a hotbox. Here is your box. You hotbox around the entire expression. That includes the H and the thing outside. There's your hotbox. You know that your C, the thing next to the H, is E. The point that you're evaluating the tangent is E. It's whatever is with the H. So my C is E, and then everything on the inside of the parentheses, make that an X. So my function is therefore natural log of X. That means my function, f of X, is the natural log of X. And this is the definition of the derivative, so I'm finding f prime of this function at E. Which of these says that? Well, f prime at E, so it's between A and B, f prime at E. And which of them is the correct function? A is the correct function, natural log of X. No questions, no questions, no one's asking for more time. Number 4. All right, I need to take the derivative and plug in -1. I don't like fractions, so I'm going to immediately turn this into the derivative of x to the -3rd minus x to the -1 plus x squared. Now I'm going to take the derivative. This is going to go, -3 comes down in front, and then it goes down a power, so it's to the -4th. And then this is going to be -1 goes down in front, so plus x to the -2. And this is going to be 2x, and then I need to plug in a -1. Whenever I plug in a -1 here, -1 to an even power is a positive, so a positive times -3 is a -3. When I plug in a -1 here, again it's to an even power, so it's going to be just a +1. And a -1 times 2 is a -2. -3 and 1 is -2. -2 and -2 is -4. Correct answer is B. No questions thus far, so we're on to number 5. This is one that you can answer with a really quick trick. So I'm looking for relative extrema. Relative extrema, if you're looking at f prime, this is f prime. If you're looking at f prime, you just need to look where there's an odd power. There's only one odd power, so the answer is 1. This one is an even power. Therefore, it's not going to switch. Whenever I draw my line, because it's an even power, it's going to be the same sign on the left and the right. So I would have -5 here, 2 here. Sorry, that's not correct. I don't know what I'm talking about here. I have a -2 here and a 5 here. This is going to switch signs over the -2 because it's an even power. It's going to be able to switch signs. But at the 5, it's going to stay the same sign. It'll be negative and negative or positive and positive, which will mean this is not a relative extrema because it has to switch signs. So the trick is, when you're looking for relative extrema, just look for an odd power. That is not the same as critical values. Critical values, you don't care about or even and odd. You're just looking for how many there are. There are 2 critical values here, but there's only 1 relative extrema. Questions? All right, number 6. Here is our function. We're looking for the line tangent, so we immediately do y minus box, which is y1, is equal to the slope box x minus x1, or box right here. We know what x is. X is -1. Let's go ahead and fill that in right away. -1. Double negative is meaning that this is going to be an x plus 1. We'll see that in the future. We need to find the derivative. Well, maybe we'll find the y1 first. When we find y1, we're plugging in -1 into each of these x values. -1 gets plugged in there and there. So -1 to the power of 3 is -1. It's an odd power. It's still negative. So -1 times 4 is a -4. So I'm going to write that above here. So that's a -4. And a -1 times a -5 is a +5 and a +3. 5 plus 3 is 8. Minus 4 is 4. So this is a 4 right there. Now we need to find our derivative because this is going to be slope. Slope is derivative. So I need to find my f prime. F prime of x is equal to, I'm going to bring down the power and multiply by the 4, so it's 12x squared minus 5, and I need to plug in my -1 again. -1 to an even power is positive, so +1 times 12 is 12, minus 5, which means f prime at -1 is equal to 7. So here's my 7. I need to distribute that 7 into each of these terms. When I distribute that 7, I'm left with, this turns into, I'll do a yellow, y is equal to, I'm going to add the 4 at the same time. I distributed the 7 to get 7x. Distribute the 7 to the +1 because negatives kiss here. So 7 is on the right hand side, but I also have to add 4, so I need a +11. There it is, C. I think I'm talking too fast, but I don't see hands, so I'm going to continue at this pace. Number 7, everyone got this one correct, so I'm going to go really fast through this one. The antiderivative is capital F, so antiderivative of this one is going to be capital F of x, evaluation bar from A to B, which means you're doing capital F of B minus capital F of A. Correct answer here is D. Number 8. Each of these values is 2, so that means this is -2, this is +2, this is -2. But we also have this +1 here, that pesky +1, which means I have to distribute this integral into each of these terms. When I do that, it looks like this. It's the integral from -3 to 3 of f of x dx. That's the first distribution. The second distribution is the integral from -3 to 3 of 1 dx. Well, we know what this thing is. That's just looking at the graph. -2 plus 2 minus 2. This thing evaluates to -2. Because you just add them up. This one is using our trick where we do end minus start, 3 minus -3, and we multiply that by whatever the number was. The number was 1. So this is really 6 times 1, which is 6. 6 minus 2, 4. C is the answer. Preguntas? Yeah, go for it.
So for the second one where it says 1 dx,
Yes.
because you don't have an x with the 1, all you're doing is basically 3 minus -3?
Yes, exactly. Whenever you just have a number, do 3 minus -3, multiply by whatever number you have. And since the number is 1, you just do 3 minus -3, and you have the answer. Yeah, good. Any other questions? All right, we're on to number 9. All right, so this one was a little bit tricky to see. I'm going to rewrite this one first as x squared times the quantity of e to the negative x cubed. It's a negative because I had to bring it to the top. If you ever use switch sides, you switch the sign of the exponent. Not the exponent of the exponent, just the exponent. Now it's easy to see, okay, well, this looks like a taxman problem because I have my dinner that's going to match up with my taxman problem. So my u is negative x to the power of 3. My taxman, he's knocking out front, he's x squared. I was mixing up my x and my equal sign. Taxman is x squared. My u prime is going to be negative 3x squared. That means I'm going to pay taxman with negative 1/3. So my new integral is going to be negative 1/3 e to the negative x cubed. And then I take the antiderivative. Antiderivative of e house is e house, which means essentially this integral goes away, and I add c. Which of those looks like that? Correct answer is C. And just as a note, I didn't mention that the e to the negative x cubed should drop to the denominator to get c, but I think we can see that. Okay, number 10. Number 10, we have basically the same type of problem because we have this product rule. There's no anti-product rule, which means we need our taxman. So u is equal to x to the power of 4. Our taxman, he's knocking out front. He is our x cubed. And u prime is equal to 4x to the power of 3, which means I'm paying taxman with 1/4. When I pay taxman, it looks like this. Integral between 0 and 1. That was a horrible integral. integral between 0 and 1 of paying the taxman with 1/4, and I still have this e to the x to the power of 4 dx. When I take the antiderivative of e house, it's the same, which means I am left with 1/4 e to the power of x to the power of 4, evaluation bar between 0 and 1. All right, now that I'm actually plugging in 1 and 0, I'm going to leave this 1/4 factored on the outside. I'll deal with you in a sec. I just want to look at e to the x to the 4. E to the x to the 4. E to the 1 to the 4 is just e to the 1. E to the 0 to the 4 is e to the 0 minus e to the 0. Well, anything to the power of 0 is just 1. Anything to the power of 1 is just e. I guess I don't really need to say that there, but this one is 1, which means I'm really left with 1/4 e minus 1. Our final answer is A. Usually this one trips up students because we forget that when we plug in 0, we actually get something out of it. A lot of times we plug in 0 and we think, oh, I don't have to do anything because it'll go to 0. Unfortunately, it's a power. Did anyone make that mistake? No? Oh, cool. We dodged the common error. Any questions so far?
How do you know u is x to the 4th?
Okay, so how do I know e is x or u is x to the 4th? Because I see what house I'm in. So I'm either in powerhouse here or I'm in e house here. If I tried powerhouse, that means that my u would be, well, I wouldn't have a u, and there would be no way to do an anti-product rule or use taxman. So if I say, okay, well, let's assume to be an e house. If I am in e house, that means my inner is this x to the power of 4. That means that my u prime is going to be the derivative of that, which is 4x to the power of 3. Oh, I have an x to the power of 3, which will get rid of this x to the power of 3. So by knowing it's e house, it allows me to get rid of that product.
So if there's an e house, it's always going to be the power that's going to be u.
Yeah, if you ever see an e, look at that power, that's going to be u. Almost every time, like 99% of the time. Yep. Good question. Other questions? All right, number 11. So this one you can even do without taxman because we've been doing them so fast. You know that taxman out front is 1. You know that u prime is going to be 3, which means we're going to pay taxman with 1/3. I'm going to go ahead and do that all in my head, and I'm going to say I'm going to pay taxman with 1/3, and I'm going to do sine of 3x. And after I do that, anti-same to take the antiderivative. Anti-same means change the sign. This is going to be a negative 1/3 cosine 3x, evaluation bar between 0 and pi over 3. Is it okay for me to skip that step without doing full taxman? This one was such an easy taxman that I figured I could skip it. But I'm really doing taxman to get this 1/3 here. I'm just doing it in my head. And hopefully by the time that the AP calculus test comes around, you should be able to do these simple taxman problems in your head too. But I don't expect that of everyone. It's just that's where we're trying to get. That's our goal. Okay, when I'm plugging in these terms, what do I get? So I'm going to leave this negative 1/3 out front and deal with him at the very end. Let's do cosine of 3 times pi over 3, which is really cosine of pi. That is going to be subtracting cosine of 0. I guess I had a parenthesis, end with parenthesis. Okay, so what is cosine of pi? Cosine of pi, if I'm looking at my graph, here's 0, here's pi over 2, which means pi is right here. Here is cosine of pi. Cosine is asking for the x coordinate, which means cosine of pi is negative 1. The x coordinate right here is negative 1. Cosine of 0, well, here's cosine of 0. It's the x coordinate here. Cosine of 0 is 1. So this problem simplifies to, I still have that negative 1/3 out front. This is going to be negative 1 minus that other positive 1, which means I have negative 1/3 times negative 2. A negative times a negative is a positive. I have positive 2/3. Correct answer is D.
How do you know it's negative 1 and 1? Shouldn't it be 0?
Negative 1 minus 1 right here. So I know that's always subtracting because I do end minus start. So that's where the minus came from.
How do you know cosine pi is negative 1?
Okay, I'll explain that again. So cosine of pi is this point right here. Do you agree that that is pi? Okay, and then cosine is saying, look for the x coordinate. This is the negative direction. This is the positive direction. So this x direction is negative 1. This x direction is positive 1 because it's on the right-hand side. If it's on the left-hand side, all the x coordinates on this hand side of the graph are negative. All the x coordinates on this right-hand side are positive. Still trying to digest?
Because I don't get how it's negative 1. So, like, say cosine of pi is negative 1. How do you know it's negative 1? What if it's negative 2?
Okay, so whenever you're doing trigonometry, you're using the unit circle. The unit circle, by definition, has a radius of 1. This is a radius of 1. This length of that segment right here is 1. This length is 1. This length is 1 because everything is on what's called the unit circle. So it has to be a negative 1. Yeah. Good question. Good question. All right. Any other questions thus far? Now's your chance. All right, number 12. So we have a review. No, this is not. This was new from this unit. So we're breaking up this integral by the suspect point. Suspect point in this case is 3. So I have the integral from 1 to 3, and I have an integral from 3 to 5. It goes from the start to the suspect point, from the suspect point to the end. So that's how I break up my integrals. The one that goes on the left is the one that's on the left-hand side, so less than, which means I'm dealing with 2, so 2 dx, and I'm adding this other integral, which is x minus 1, x minus 1, all of that dx. Now I have to do each of them independently. So this antiderivative of 2 is 2x. That's a valuation bar between 1 and 3. This antiderivative is x squared over 2 minus x between 3 and 5. When I do that evaluation, when I plug in 3 and 1, I get 3 times 2. All right, I guess I can keep the 2 outside. 2 times the quantity of 3 minus 1. Whenever you have a coefficient outside, you can leave it at until the very end. So I'm just doing the inner workings, which just happen to be the evaluation bar. So 3 minus 1, and then I have the 2 at the very end. So that's this problem right here. And that eventually is going to turn into a 4 because 3 minus 1 is 2, 2 times 2 is 4. Let's deal with this second part. The second part is a little bit more tricky, and I'll show that in a different color. Let's choose yellow. So when I choose 5, it's going to be 25 over 2. So it's going to be adding to 25 over 2 minus this x, which is 5. That's the first part, and this has to subtract the start. The start was 3, so it's going to be 9 over 2 minus 3. The trick here is subtract the over 2's first. Do 25 over 2 minus the 9 over 2. 25 minus 9 is 16. So 16 over 2, I really have 16 over 2, and then I have minus 5 minus negative 3, so minus 2 here. Well, 16 divided by 2 is 8. 8 minus 2 is 6. So I'm really adding 6 and 4. 6 and 4 makes 10. D. Questions, questions, questions? No questions? All right. Number 13. Every single person got number 13 correct, all 3 of us. So let me do this nice and quick. So we know that this has an area of 1 here. Break this up here. This has an area of 2. This has an area of 1. This has an area right here of negative 0.5 or negative 1/2. This has an area of negative 1, which means that 1 and that negative 1 cancel each other out. I'm left with 2 plus 1 minus 0.5, which is 2.5. Correct answer, B. Going on to number 14. All right, so number 14, we're on the next side. We are trying to take the antiderivative. The problem is our dinner here is 3. It's not 1, which means we need taxman. Our u is on the inside. That's our 3x plus 1. Our taxman, there is no taxman, so he's 1. Our u prime is equal to 3. We're paying taxman with 1/3. So my new integral is now 1/3 of the original, which is 3x plus 1 to the power of 5 dx. Take the antiderivative, and I have 1/3 times 3x plus 1. It goes up a power to the power of 6. Divide by 6, so I have to multiply by 1/6. Which of these is divided by 18? Because 3 times 6 is 18. Which of these are divided by 18? There's only one of them. It's A. A is the answer. Questions, questions, questions. People are writing, but I don't see any hands, so I'm going to continue on. Number 15. All right, so this guy. Looks like we're doing taxman, so it looks like I'm going to rewrite this just because I don't like square roots. It's x times 4 minus x squared to the power of 1/2. Let's go ahead and say, okay, this is powerhouse, so we're going to be dealing with taxman. U is equal to 4 minus x squared. Taxman is out front, he's x, and u prime is negative 2x. Ooh, negative 2x. I wonder if anyone got tripped up by the negative. So x divided by x, that cancels out the x's, and I'm left with paying the taxman negative 1/2. So my new integral here is negative 1/2 of this 4 minus x squared to the 1/2. When I take the antiderivative of this, that means I'm still left with this negative 1/2. I still have this 4 minus x squared, but now I'm going to go up a power. I have to add 2 over 2, so that's 3 over 2. And I have to also divide by 3/2, which is the same thing as multiplying by 2/3. So 2/3, and notice here that the 2's will cancel each other out, 2 and 2. So I really have negative 1/3 of all of this. Which one of these looks like negative 1/3? It looks like to me that one has an x squared, so it's E. People still writing, but no hands, so I'm continuing on to number 16. Number 16 is a pretty short and sweet problem. I'm going to rewrite this from 1 to 2 of x to the negative 2 dx, and from there I'm going to add a power, so x to the negative 1, divide down, becomes a negative, and then I have to add my plus c, nope, evaluation bar instead, from 1 to 2, so that's going to turn into this. I don't like writing negative powers, so whenever I see a negative power and I have to evaluate it, I always rewrite it as negative 1 over x, evaluation bar between 1 and 2. Now it's easier for my mind to comprehend, okay, yeah, 2 and 1 are going to be in the denominator. So when I plug in 2 and 1, I get negative 1 over, and I'm plugging in 2, and I'm going to subtract. I still have a negative, so there's 2 negatives, be careful there, and I have 1 over, and I'm plugging in 1. So double negatives, kiss makes a positive, and I'm really asking, what is 1 minus 1/2? Well, 1 minus a half is just a half, so correct answer is C. Short and sweet, but it is tricky with those negatives, so be careful. Number 17. Number 17, what do we want to do here? So if it says that y prime, remember dy dx is the same thing as y prime. If y prime is equal to cosine of 2x, then to get y, I have to take the antiderivative to get rid of that prime. So I'm really asking, what is the antiderivative of cosine of 2x dx? Cosine 2x dx. Okay, well, I know that I'm going to have to use taxman because my inner is 2x. That means my derivative of the inner is 2. It's not 1. I can do taxman in my head. This is easy. Taxman, there's nothing out front, so that's 1 over, and then derivative of 2x is 2. I'm paying the taxman with 1/2. Okay, I'm taking the antiderivative all at the same time. I'm doing all of these steps together. Anti-change, because C stands for change. Anti-change means same, so same sign, don't switch the sign, and cosine turns into a sine, and then we have a 2x. And then don't forget your plus C. Which of these is 1/2 sine 2x plus C? It looks like it is C. No questions, no questions. No one wants me to slow down. We're on to number 18. All right, number 18, it looks like we're going to just distribute this integral from 0 to 2 on both of these terms. So when I do that, I'm just going to take the antiderivative. It's 2x going up a power to the power of 4, dividing down by that 4. And I'm going to add 3x, an evaluation bar between 0 and 2. I know that when I'm evaluating, this is really 1 there, and this is really 2 there. I'm simplifying that fraction, and then I go ahead and actually plug them in. When I plug in 2, I'm going to get 2 to the power of 4 divided by 2, which is really the same thing as 2 to the power of 3. And I know in my head, 2 to the power of 3 is 8. So it's 8 plus 3 times 2 is 6. There's the first half when I plugged in 2. Then when I plug in 0, I get 0 plus 0. So minus 0 plus 0, I don't really have to worry about it. 8 plus 6 is 14. Correct answer is C. I know I go fast, but it seems like you guys are okay. You will raise your hand, hopefully, if you want me to slow down, and no one has done that. We're on number 19. All right, this one, every single person missed. All 3 of us. So let's step back and make sure that we all know how to do this one. You can't take the antiderivative because to take the antiderivative, you would have to use taxman. Taxman would suggest that u, let's show you why this doesn't work, you would suggest that u is equal to x squared plus 1. Taxman would be 1. U prime would be 2x. Uh-oh, we can't pay the taxman a variable rate of 1 over 2x. We cannot do that. So we have to find a different method, and this was on the homework too, where if you can't pay him a variable rate, go ahead and simplify this expression first and then do it. I can square a number. We know how to square things. Square things means you square the first, double the product, square the last. So square the first. X squared squared is x to the 4th. Double the product. X squared times 1, that's the product. X squared times 1 is just x squared. Double x squared is 2x squared. And square the last. 1 squared is 1. This whole thing, dx. I have simplified, well, I don't know if you consider it to be simplified, but I've definitely expanded this expression now to the point where I can use my normal rules to make this work. After multiplying this out, I can now get the antiderivative, and I don't need to do that now. It's going to be x to the power of 5 divided by 5 plus 2x to the power of 3 divided by 3. That was about 3. And then plus x, and then plus c, and which of those looks like it? It is E. Verbatim, what I've just written, it's right there for E. So key thing, when you can't pay the variable, or when you can't pay taxman a variable rate. So because you can't do that, you need to find the different method, which usually involves somehow using your algebra skills to simplify that expression. There will be one of these on the test. You've been warned. All right, number 20. Last question. This one I'm going to rewrite because I don't like fractions. When I rewrite this, this is the integral from 2 to 3 of x. That's going to be our taxman. He's knocking at the front door, and on the inside I have x squared plus 1 to the power of negative 1. It's to the negative 1 because I brought it to the numerator. Whenever you switch these, it turns to a negative. Don't forget your dx. Now when I evaluate this thing, I know that my u is going to be x squared plus 1. I know that my taxman is going to be knocking out front. My taxman is x, and then my u prime is equal to 2x. Luckily, we don't have a variable right here. The x's cancel out, and I'm left with 1/2. I'm paying the taxman now from 2 to 3. I'm paying him 1/2, and I still have this x squared plus 1 to the power of negative 1. This is one of those special rules. You can't add 1 because then you'll be dividing by 0. This is the natural logarithm. So this is going to be natural logarithm of x squared plus 1. Don't forget your 1/2 out front. I almost did. And that's going to be evaluation bar between 2 and 3. I did not use absolute value signs here because x squared plus 1 can never be a negative value. We usually have absolute values here just in case it could be, but this can never be this can never be a negative unless you're in complex numbers, which you never are for AP Calculus. So plugging in 3, this is going to be 1/2. We'll leave that on the outside. Don't worry about that 1/2. Just worry about plugging into the natural logarithm. So when I do 1/2, 3 gets plugged in. 3 squared, 9 plus 1 is 10. So natural logarithm of 10. And then I need to subtract whatever I plugged in 2. 2 squared is 4 plus 1 is 5. Natural log of 5. There is our answer. I'm going to go ahead and distribute that, and it looks like we get E for our answer. And that concludes all the pretests, probably in a record time because no one paused me that often. I hope that you guys all understand it. Are there any questions now that we've gone over everything? We're ready for the test? Yeah, question. Number 19, yes. Ask your question.
I don't get how you got 2x squared.
2x squared. You don't understand this term right here?
Because I see how you got x to the 4th because you applied the 2 onto x squared, which turns to x to the power 4.
Perfect. Can I explain this a different way with a picture? I think it might be a little bit easier. When I say x squared plus 1 times 2, I'm really saying x squared plus 1 times x squared plus 1. I can use the box rule, and I think you're the one that showed me this too. The box like this, where this is x squared plus 1. This is x squared plus 1. X squared times x squared, Rochelle, is? X squared times 1 is? X squared times 1 is? 1 times 1 is? Add all of these up. I get x to the power of 4. X squared plus x squared is? Careful when you're adding. You're just counting how many there are. How many x squareds are there? So 2x squared. Yep. Plus 1. So this is the picture way of doing this in case you don't know the rule. Square this first, double the product, square the last. Just use the picture. Yeah, good question, good question. Any other questions? All right, that concludes the pretest. Let's work on our fix-up.